Okay, so I'm going to click on apply, forward, and then reservoir. Okay, so this is very important section. Wait a minute. Okay, so yep, go to general, the name of our reservoir, I call this sand, and the pressure in PSIG, it's 800 PSIG, the temperature 186 degrees Fahrenheit, and the mid perf depth, the location of the middle of perforation. Let me check my correct value first. So it's going to be at 3,317. Okay. And the permeability, let me check my value again. The permeability for my reservoir, it's 79. Okay. It's 79 millidarcies. All right. And then the thickness in TVD, the thickness of my reservoir, it's 53 feet, wellbore radius 0.35, and water cut 100%. It's a water source well. And here you can see the productivity index will be calculated. And then for the IPR modeling, I'm going to use Vogel equation with Vogel coefficient of 0.2. And to have a better calculation, I use calculated skin in this model. Okay, and drainage area geometry, I'm going to use 250 meters. It's a typical value, and drainage shape is circular shape. And then IPR, so it's like this. We have the absolute open flow, 4,398.99. And skin, let's see the skin modeling. Completion type, it's a cased hole well. And the nearest measured formation distance from my top perforation. Let me check my value first. So it's about 3 feet. Okay, so the top reservoir, the distance from the top reservoir to my top perforation, this is the nearest distance, it's 3 foot. Okay, and then vertical permeability, I'm going to use 10% of the horizontal permeability, so it will be 7.9. And then open interval, I will perforate my well 40 feet long. Okay, so the perforation interval will be 40 feet long. So the calculated limited entry skin, it's 1.3, quite small. And then the deviation skin, for deviation skin, let me check my value first. So I will use my deviation skin because it's, okay, so it's a directional well, and the deviation is 27. Okay, so I'm going to have a small negative skin. Okay, I like that. I like negative skin. It improves my productivity, although not very significantly. And then perforation. We also want to calculate the perforation skin, the skin due to perforation. So the perforation diameter will be 0.26 inches. And crash zone, I don't have reference data for that, so I will uncheck that. Shot penetration 1 feet, 1 foot, and shot density 6 shot per foot, and shot facing 60 degrees usually, and flow shape factor, you can use lock, Egan, and then Tarik, okay, and Muscat. The template, the format is lock. Okay, so we can use that lock. So the perforation skin, lock will give me the lowest skin, lowest positive skin. So let me use this value. So the final productivity index is 9.3 or 9.4 stock tank barrel per day per PSI. which leads to absolute open flow or maximum flow rate of 5,400, and the final total Darcy skin is 2.9, which is good. So let's check the IPR. So it's the new IPR. Okay. So I will click on apply and deviation. Okay.